Okay, so guys, in the earlier sessions, did I show you how to install the Windows 7 VMX file by any chance? We already have the Kali installation, but I'm not sure if I've shown the Windows 7 installation or not. Did I show it? I didn't, right? Did I share the zip file at least, the Windows 7 zip file? I didn't share it in the earlier sessions. Okay. I'm going to share two more virtual machines today, guys. So Kali is going to act as our attacker machine on which we have the Nmap. But with Nmap, we have to scan other systems, right? So I'm going to share two new virtual machines today. One is a Windows 7 virtual machine, and one more is called Metasploitable. Okay, so this is the other one which I'll be sharing. Now, this Metasploitable is a Linux virtual machine, guys, and this is basically an intentionally vulnerable Linux virtual machine. So this has been created specifically to conduct security training on. Okay, it contains a lot of vulnerable services. It contains a lot of ports open. Okay, on which you can perform practice or common pen testing techniques. Okay, again, it's a completely terminal-based operating system. You won't have any graphical interface on it. I'm going to show you today how to install this virtual machine. Okay. So first things first, let me remove them from my VMware setup, just so that I can show you the installation. So, yeah. So again, I'm going to share the files right now. First, you can download them after the class and perform the installation. Yeah. So this is the Metasploitable link, guys. And I also share the Windows 7 as well. Hmm. I thought I sent the Windows 7 already. Windows 7. Yeah. Right. Okay, I've sent you the files, guys. Now, when you click on that, again, you'll get zip files for both Windows 7 and Metasploitable. So when I click on this, you should get my drive access. And you can download the files from here. Both of them are zip files again. So once the files are downloaded, same procedure, just like how we installed Kali, you have to download them, extract them, and open the VMX file. So this is what the files would look like, the Metasploitable file and the Windows 7 file. So first things first, if I want to install Windows 7, right click, show more options, 7-zip, and extract to Windows 7. Okay. So when I hit enter, this should start extracting the file. And these are double compressed, guys. So you have to extract them twice actually, unlike Kali, which is again single compress. So once extraction is done, you'll find one more zip file. You have to extract it again. I'll show you. Mhm. Yeah. So it should be done in around 40-50 seconds or so. And once this is done, you would have a folder as such. And in that folder, you will find one more zip file. Right click. Again, same thing. Show more options, 7-zip, extract. And once extracted in that folder, you would find the VMX file. Just click on it and import it in VMware after that. So after this extraction is done, if you want, you can delete this older zip file. That's not required anymore. Okay, so you can save up some space. And in this, you see there's a VMX file. Double click on it, and that automatically pops up in your VMware. Default settings, guys, nothing to change much here. Memory 1 GB. If you want, you can give 2 GB as well, your choice. processor, one processor, network adapter, bridged adapter. That's it, nothing more. Click on OK, click on power on, and this should start your Windows 7. And if you get this error by any chance, if you don't know what to click, just click on I copied it. And that should start the Windows 7 for you. Once this is installed, guys, I would recommend creating a snapshot. So let me explain what that is. So basically, snapshot is like a restore point, or ignore that for now. I'll talk about snapshots in a later session. Okay, but basically, you get a login screen here where you'll have a user called root, and you can log into that. Okay, and if the screen resolution is not right, you can change that. Click work network here, and if this resolution is not fine, screen resolution, set the resolution according to your compatible screen size. Okay, so this is your Windows 7 virtual machine now. Okay. And anything else that I forgot to mention here? Yeah, your system does not have a password. So if you want, you can create a password for your device. Okay. So yeah, this is your Windows 7 working version of Windows 7. Okay. Now, simultaneously, there's one more file as well as mentioned, Metasploitable. Let's extract that also. So this is the folder here. I'm going to right click on that. Show more options, 7-zip, extract. Again, double compressed. So once you get the folder, within that, you'll have one more zip file. You got to extract that as well. Right click, show more options, 7-zip, extract. And you can delete the older zip file. And you see there's a VMX file here. Double click on it. That imports in your VMware again. Okay. And this is a lightweight operating system, guys, completely terminal based. So memory 512 MB is more than sufficient, half a G. Okay. So it says recommended is 4 GB. That's wrong information. You can ignore that. 512 MB is more than sufficient. Processor, one processor. Hard drive space, right now it's currently running on 19 megabytes. That's all. That's the size of the operating system. Very small, very lightweight operating system. And it has two network adapters actually. So put them in bridged mode. Both of them. Once they are in bridge mode, you can click on power on. And that should start the operating system for you. And once started up, username and password are mentioned on the screen itself. So it has a default login, username MSF admin and password MSF admin. Everything in lowercase. Let me show you. So again, all you see is a black screen, guys, and you'll have some data in white color and white colored font, nothing more. Okay, so if you see, this is what the operating system basically looks like. Okay, nothing more. So if you see, username and password has been mentioned here itself. Username, MSF admin, and MSF admin. And if you want, you can maximize the screen as you can click on this button here, and that increases the screen size, fits to your screen. And you can see username and password are mentioned here. Type username MSF admin. And password also the same one. But when you enter the password, it won't be visible for Linux security reasons. Just type the correct password and hit enter. Okay. And all you need is this machine's IP address. That's all. You just need to keep this machine active. And on this active running system, we perform the practicals, scanning or pen testing practicals. Okay. So this is my Metasploitable system here, my Linux target, and this is my Windows 7, a Windows target. Okay. And now we can use our Kali system to perform scanning on it or penetration testing. So this is the required lab setup, an attacker machine and two victim machines, one of each platform, Windows and Linux. Okay. Is that clear? Any questions on this up to here? Shekhar, Bhavin, G1. Yes. So we are running three virtual machines at the moment. One is our Kali attacker machine, and the other two are victim machines. One a Linux machine and one a Windows machine. Right, Shekhar? Yeah, it's called Metasploitable. Basically, it gets its name from a tool called Metasploit. So again, if you read the name here, it's called Metasploitable. So in our upcoming session, Sorry? Yeah, it's an OS, it's an operating system. So there's a tool called Metasploit Framework. This is a penetration testing tool. Okay. So we'll be working on this in the upcoming sessions. So what penetration testers did or what security researchers did is to understand this tool, they built another operating system. And to attack on it, we use the Metasploit framework. Hence they named it Metasploitable. Okay. A system exploitable with Metasploit framework. That's how it gets its name. So Metasploitable is an operating system. Okay. It's an intentionally vulnerable Linux virtual machine. Okay. On which you can perform pen testing practicals. Okay. So it gets its name from this framework called Metasploit. So there's a common confusion. What is Metasploit and what is Metasploitable? Metasploit is the pen testing framework used to attack other systems. And Metasploitable was built as an example operating system on which you can perform the attacks. Okay. Is that clear? Right. So again, that is how you install it, guys. A very lightweight operating system again, as mentioned. And now you can use your Kali operating system to perform scanning on it if you want. Okay. So first things first, again, an important point to note with Nmap, guys, is Nmap when you perform scanning with it, it performs and checks all the ports on the target system. But sometimes these ports might be blocked by a firewall. So it's better to get maximum results on your Windows target system, shut down the firewall. Okay, in real time as well, when you perform scan, you request the network administrator to add a rule for you to perform scans. Okay, so they will not switch off the firewall in such a case. They'll just add an ECL, an access control list with your IP to allow your packets from Nmap. Okay. Or you can also perform scanning during the maintenance hours when you can shut down the firewall and keep it off production. Okay. So over here for my Windows system, I'm going to switch off the firewall. Okay. For Metasploitable, you don't need that because it doesn't have a firewall by default. Okay. So for Windows, I'm going to switch off the firewall. And here, right now, my Windows system is getting the IP of 192.168.0.5. Okay. And Metasploitable is getting 0.7. And my Kali here is 0.4. Okay, so these are the IPs. All of them are in the same network, and I can perform scanning on them now. So the first scan type that we're going to learn today with Nmap is the ping scan. So if I go back to my presentation here, as mentioned, Nmap has a certain syntax to it, guys. You type Nmap first, and then you specify a scan type, and then you can specify an option if required, and then you can scan a single IP, a range of IPs, or a domain name as well. So the first scan type we're going to learn is the ping scan with -SN. So ping scan is basically to perform network host discovery, figuring out in your local network how many devices are active. Okay. So to perform ping scan, you type Nmap first, and the scan type, which is -SN for ping scan. So this is the word that you have to use for ping scan, SN. Okay. So every scan has a unique option for it this way. Okay. And now you can scan a singular IP if you want. So if I scan my router's IP 0.1, and if I hit enter, this is the result I get from ping scan. So first, again, let me break down the results. So in the first line, it says starting Nmap, so-and-so version 7.94 is what is running right now at this exact time right now. So in my system, that's the default time set. And it says Nmap report for that IP is, again, this host is up. So with ping scan, you only get information whether the device is active or not. Okay, checking in your network by pinging a certain system and letting you know the device is alive. So again, scanning a single IP might not be useful in any way, but you can scan the entire network as well. So if I give 1-255, now it scans the entire network. And from your device, now you can figure out how many other devices are active in the network. So now when I hit enter, you can see it performs a scan. Might take slightly longer. So when I scanned only single IP, it took 0.13 seconds or something. But now since I'm scanning the entire network, it will take slightly longer, 11 seconds or so. And it tells me now in my entire network how many devices are active. So out of all the 255 IP scanned, 6 devices are active right now in my network. 0.1 is active, 0.2 is active, 0.3 is active, 5 is active, 7 is active, and 4 is active. Now, if you notice for 4, it is mentioned in the end. Up to here, it's in a very numerical order. But the last IP4 is basically your Kali systems IP. So whatever IP is mentioned there, it's your Kali systems IP. Okay, and these are the other active devices in the network. So excluding your IP device, your Kali's IP, there are 5 other devices in your network. And if you notice, when I'm scanning my Windows 7 and Metasploitable, it clearly mentions they are virtual machines. They are running on VMware. So it can also mention the vendor name. Okay. So from Nmap, you can also figure out if it's a router, if it's a physical device or a virtual machine as well. Okay. So this is ping scan, guys, used to perform host discovery by pinging every system in the network. Okay. So this is our first scan type. And as mentioned, you can also scan a domain name. So if I type nmap -sn, I can also mention a domain name, www.google.com. And now it pings Google's IP and lets you know if the host is reachable or not. Okay, so that's how you can perform Nmap scans. Nmap, a scan type, and a single IP, a range of IPs or a domain name. Okay, moving forward, after ping scan, we have TCP connect scan. Now this is to figure out on the target system what TCP ports are open. Okay, so let's say if I want to scan my Metasploitable system here and figure out what TCP ports are open on it, I can type nmap -s capital T for TCP scan and the target IP 192.168.0.7. Let me check. Yeah, 0.7, correct IP. So now when I hit enter, it now performs a TCP scan and tells us what TCP ports are open on the target. So this is not a host discovery scan case. This is a different scan type to give you information on what ports are open. So let me break down the results again. So it says first line, starting nmap so-and-so version at so-and-so time, nmap report for that IP which we have scanned. So first it tells us that the host is active. It did perform a ping scan first. And then it says not shown 977 closed ports. So basically what this means is by default, guys, nmap scans for 1,000 important ports on the target system. So out of all the 65,535 ports, 65535 ports, it scans for the most important 1,000 ports. So out of those 1,000 ports, it says 977 ports are closed and these remaining ports are shown as open. So first it gives me the port number, then the state of the port and the service running on that port. So port 21 is open and running FTP on it. 22 is open, running SSH on it. 23 is open, running Telnet on it. 25 is open, running SMTP on it. As such, it mentions which ports are open, which ports are not, and what services are running on those. This is a Nmaps ST or TCP connect scan. Okay. Now, moving on to the next scan type, there's something called SYN scan. Now, when I run the SYN scan with SS, carefully observe, guys. So I'll run it side by side. So this is my ST here. And if I open up another terminal, oh, sorry. Split vertically. Yeah. So now when I hit the command nmap -s capitalist for SYN scan and the same IP 0.7, carefully observe, I actually get very similar results. Not much difference. 977 closed ports, 977 closed ports. Same number of ports open here. Same number of ports open here. Okay, so if you notice the end result here for both these scan types is quite similar. Okay, but do you notice any difference at all in these results? Can you figure out if you see any certain difference in these scan results? Any certain word that is different? Is it what? No, 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 not the time. That is quite similar. 0.00. Uh-huh. Right. Good. Yeah, that's a good difference actually. Again, you now the reason here, guys, I've asked you to note a difference is basically that itself, connection refused and reset. So basically, both of these scan types, SS and ST, are to give you the same output. What TCP ports are open, but the mechanism of how they figure that out is what is different. Okay, so TCP scan figures it out in a certain way. SYN scan has a different mechanism. Okay, and the end result is same though, but what happens in the background to figure that information out is different. Okay, so to explain this difference, let me use a diagram. So Nmap's TCP scan is also commonly known as TCP connect scan. So if I show you this, so what happens in Nmap's TCP connect scan is, if these are the two devices, and let's say this is my TCP connect scan. Okay, so from Nmap's system, the Kali system, it uses a certain port, and on the target system, whatever ports it's scanning here. Now my Nmap sends a SYN flag, SYN, right? For that SYN flag, whichever port is open, in return, it sends what? What does it send back, guys? But when a port is open, if you recall from our last class, when a port is open, yeah, it sends a SYN flag, an acknowledgement for that SYN flag. And if the port is closed, what does it send? If the port is closed, it sends a reset flag, RST. Okay. So right now, when the port is open, it sends a SYN-ACK back. From this SYN-ACK, the job is done actually. It gets to know what ports are open. And if it is getting reset, it gets to know what ports are closed. Yet, even after receiving SYN-ACK, what your Nmap does is it still sends an ACK flag on that port. So with that SYN-ACK, and ACK, this becomes your TCP three-way handshake. So whenever a TCP three-way handshake is performed, a connection is established now here. Okay. So on every open port, a TCP three-way handshake. Oh, sorry, it's getting cut. A TCP three-way handshake is performed now by Nmap. And whenever a TCP three-way handshake is performed, a connection or a log is initiated. And now the target knows who exactly performed the scan. Okay, so that is why it is also commonly known as connect scan or full scan, because it performs a complete TCP three-way handshake in fully. Okay, now that is why you have another scan type called SS, which is also commonly known as SYN scan or stealth scan. So what happens in stealth or SYN scan here is whatever ports are open here now, your Nmap now sends a SYN flag, SYN. From that SYN flag, whichever ports are open, you receive a SYN-ACK, SYN-ACK. And once you get that SYN-ACK, and once Nmap gets to know what ports are open and what ports are not, it sends a reset flag now. Okay. So rather than sending an ACK now, it sends a reset to reject the communication. So midway, rather than performing the complete TCP three-way handshake, it terminates the connection in between. So therefore, it doesn't establish a connection on any open port. So no connections are established. No connections are established on the open ports. And since no connections are established, no log is initiated. And since no log is initiated, the target doesn't know who performed the scan. And that's why this is also commonly known as stealth scan or half open scan. These are the names given for SYN scan, half open scan. Okay. So again, this is performed when you have no tension on who gets to know what your IP is or not. And this is performed when you don't want to give out your IP to the target system. Okay. One gives out very open information that I am performing a scan on you, and the other one doesn't do it. It does it a bit discreetly. Okay. And that is why, if you notice over here, it shows connection refused and reset. So in SYN scan, since it's sending reset in the end, it shows reset there. Here it says connection refused because after the TCP connection is formed, that port, again, your system then sends a reset flag. So in the end, again, after the TCP three-way handshake, then it sends a reset to reject the communication. Okay. That is useless anyhow. After that, after you have initiated a connection, then closing the connection is useless because you've already given out your information. So that's why it shows connection refused here. Okay. I can show this a bit more practically, guys, in the upcoming sessions. We'll be using a tool called Wireshark. It's a packet analyzer. So in that packet analyzer, I can actually show these packets to you: SYN flag, SYN-ACK, ACK, all this. Okay. You can clearly note the difference between the TCP scan and the SYN scan. Okay. So that is what is, again, TCP connect scan and SYN stealth scan. Okay. And this is also commonly asked question in examinations. If you don't mention a scan type, what happens then? So if I type Nmap, and if I just mention an IP rather than any scan type, what would happen then? What would Nmap use by default? So when I hit enter, you can clearly observe it shows here reset. And when it shows reset, what does it mean, guys? It's using the SYN scan. Okay, because SYN is using reset here, right? So again, a very commonly asked question in interviews and in examinations as well. If you don't mention a scan type with Nmap, what does it use by default? It uses a reset. It uses a SYN scan by default. Okay, the half open scan. Okay. So that is the main difference, guys, or the mechanism on how Nmap is working these scans out. Okay. So over here, that's what I've mentioned in description as well. In TCP connect scan, this is used to scan TCP ports, and in the process, it performs TCP three-way handshake on each open port, also commonly known as connect scan. On the other hand, when you talk about SYN scan, used to scan for TCP ports stealthily. also known as half open scan or stealthy scan. Okay. Nmap by default uses the scan type. Okay, that's about SYN-SCAN. Then we have UDP scan. Now, as mentioned, all devices, guys, have two types of ports, one TCP ports and the other one UDP ports. So if you want to figure out what UDP ports are open on the target, you go for UDP scan. And that is run with the option nmap -s capital U for UDP scan. And then you mention the target IP. And now when I hit enter, it should initiate the scan for us. Okay, so yeah. Now, does anyone find something fishy here? Do you find something odd with UDP scan? Can anyone think that maybe something is wrong with the scan type? Something doesn't make sense. Yeah. Can you elaborate on that, Jiva? You're there actually. You're giving me the answer. Okay, yeah, go on. Sorry. Yeah. Mhm. Mm, yes, sending packets and receiving packets. But that happens in any connection, right, Jivan? What do you mean by packets? And UDP also we send packets, we receive packets. Can you elaborate a bit more? You need to use a certain term actually. You're there actually. You've given me a correct answer, but you're missing out some words. Very, very important words you're missing out. Any other answers? Any answers from others, guys? Bhavin, Shekhar, can you expand on what Jeevan spoke? He has given me the correct answer actually. Very close, but some wordings are missing. Okay, let me give you a hint, Jeevan. What are these called? The synac, act, reset. What do you call these? No, 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 no. TCP only, but they're not called packets. They have a certain name to it. I've been using it a lot of times. What are they called? They're called flags, right? Right. And that's the word I was looking for. So in UDP, guys, we don't, again, in UDP also you have packets, if you remember. When data is being transmitted using UDP protocol also, you have data packets sent. What you don't have in UDP is flags, okay? Like TCP, when you have SYN flag, SYNAC flag, ACK flag, reset flag, and all that. In UDP, there are no flags as such. And if you remember, Nmap predominantly works on the basis of flags itself. Without flags, without these TCP flags, Nmap has no usage. Nmap cannot run. It works on the basis of these TCP flags. And here, how is Nmap performing a UDP scan? Because in UDP, you don't have flags at all, right? So over here, Nmap needs to build a special packet for every UDP protocol. For example, if it's a DNS protocol, it needs to send a DNS request or DNS probe. If it's a DHCP protocol, it needs to send the discover packet in the DORA process. So that creation of every packet, every specially crafted packet for every UDP protocol is a very time-taking process. And that is why if you notice over here, I'm not getting any results because unlike TCP scan, which is done in like 1 or 2 seconds, UDP takes a lot of minutes to complete. So you might again you might get the results at least after 10-15 minutes, okay, for UDP. Okay. So if I scroll down my mouse wheel, actually you can see how much scan has completed. So if you keep scrolling down your mouse wheel in the terminal, you get update here telling 21% done, 22% done, etc. And it's going to take at least 13 minutes more if you notice over here. But if you want to get a detailed output of the background process, you can stop this now, Control C to stop a process. And now you can run a scan with an option called -v for verbose. So as you were UDP scan, target IP. And in the end now, I can add an option. So this is the first option we're going to discuss. -v for verbose. You can add V or VV, anything works, very verbose. Okay. And now when I hit enter, it gives me a detailed output of what is happening in the background. So it shows Nmap has initiated a ping scan here, okay, starting Nmap so-and-so version. It initiated a ping scan to check if the device is active or not. And now it is initiating the UDP scan at so and so time. So it is scanning 1,000 ports on the target system. And whenever a packet is being blocked, it is increasing certain delay and then sending the packets again. Okay, and it gives you a timely update of what is happening in the background, how much scan has completed, again, how much longer will it take to complete the scan. Okay. So -VV gives you a detailed output rather than just giving you a blank screen. Okay. So again, as mentioned, in UDP scan, there are no flags. Since there are no flags, Nmap needs to create a special packet for every UDP protocol. And that will be a time-taking process. An assignment for you today is to give me the result of UDP scan, if possible, by the next class. Okay. So what you can do is you can just take a screenshot. You can run the UDP scan on your Metasploitable device and just take a screenshot of it if possible. You can take a screen capture and send it to me on WhatsApp or over the email. Okay, for the end result with UDP scan. Okay, so that is what UDP scan is, to scan the UDP ports on the target system. Okay, so used to scan for UDP ports on the target. Then we have the next scan type, port scan without ping. Now, this is a scan type which doesn't send a ping packet first. So basically, sometimes firewalls block ICMP packets, okay, which is used in the ping protocol. So again, when the ping is blocked, your Nmap cannot perform the scan for the upcoming ports. So when I run an Nmap scan, let's say if I run a SYN scan as well, if I open up another terminal, and if I run Nmap -S, capital S for SYN scan, and if I give the target IP 0.7, and if I give -V for verbose, carefully observe, first it performs a ping scan, checks if the device is active or not, and then it performs a SYN scan and tells you which ports are open and which ports are not. Now, sometimes what happens is this ping scan gets blocked by firewalls. And when ping is blocked, it cannot perform the upcoming SYN scan. Okay. So that is why you have an option in Nmap called Nmap-P, capital N. So this is a command to do not perform ping scan. Okay, just directly perform this TCP scan on the target IP. So now when I hit 0.7 and if I hit enter, it directly gives me the port results without performing ping. Okay, so again, as mentioned, used to perform TCP port scan without pinging the target first. Helpful in bypassing firewalls, which are blocking ping packets. Okay, so again, this is a brief intro, guys, on some of the important scan types in Nmap. There's a couple more as well. We'll talk about these in the upcoming sessions. So we have version scan, we have ACK scan, we have fin scan, we have Xmas scan, null scan, etc., etc. We'll talk about these in the upcoming sessions. Okay. So again, a brief intro, guys, on how to set up a lab for your Nmap practicals and some important scan types to discuss. How to scan TCP ports and UDP ports on the target. Okay. So we have a couple more scan types. We have a lot more options. We'll cover those in the upcoming sessions anyhow. Okay. Any questions or doubts before we exit the session today? Bhavin, G1, Shekhar. Yeah. Again, yeah, definitely. Are you talking about this on the target system, Shekhar, by any chance, or on the attacker machine? Yes. So on the target system, to log this, you can use a packet analyzer. So if you have a tool like Wireshark, there you can log that traffic, whatever packets are being received on the system. So you need a separate tool for it. Or in organizations, what they do is they use something called SIEM tools, SIEM tools. I think I did mention about this earlier. These tools are capable of capturing all these logs from various systems. So you can either check it out in that SIEM tool, or you can use a target packet analyzer, a tool like Wireshark. So this Wireshark tool is capable of capturing all the packets coming in the system or going out of the system on the target. So you can install a Wireshark tool in the network and figure out, okay, so this is capable of logging all that packets coming in or going out of the network from any scan. Hello. Yeah. No, no, there is no such way, Shekhar. Whenever a packet is being sent to a target system, again, that packet will definitely be captured in a packet analyzer tool. So again, that is not possible. You will definitely see these packets coming in or going out of the network. The only thing is if they can bypass a firewall, you can perform these attacks. Okay. So in our scenario here, the main thing that we see is if these packets are being allowed to bypass a firewall. If they're being allowed to bypass a firewall, what information are you able to get out of these packets? Okay. And again, if you get some information out, And if that information it allows you to find any vulnerabilities, you can attack on those vulnerabilities. So there is no way of not capturing the information. Okay. Your information will definitely get captured if you're using certain tools. If you're not using those tools, there is no way. So if you're performing this on a person who doesn't know these tools like Wireshark or SimTools and all, he won't even know that someone is performing a scan on his device unless and until he checks it with these tools. So all of this happens discreetly in the background. But if you're a techie guy who knows to use these tools like Wireshark and all, then you can figure out that something is wrong. Okay. If not, if I perform a ping scan on my device will give me no info about it. Okay. There's no notification, there is no lag or anything. This all happens in the background. So if I run a scan on this Windows 7 system here, which is running on 0.5, if I type nmap -s capital T for TCP scan, and if I give the target IP, and if I hit enter, nothing happens on my Windows 7 here. Everything works perfectly fine. I can open up my file explorer. Nothing seems to happen. No lag, no nothing. Okay. But you can see I've got the results here. Okay. So unless and until you're using a packet analyzer, you cannot figure out that someone is performing scanning on your device. Right. But definitely in organizations, there will be someone who's monitoring all this. So in organizations, there's no chance. You will definitely figure out that this is happening in the background. Okay, with these tools. So, yeah. All right. Any other questions, Bhavan, Jeevan? Yeah. Then you have not used the same adapter to connect all of them. So as mentioned, you have to put all of them in bridge mode. So if it is in NAT mode, then it will get a different type. So all the virtual machines should be put in bridge mode. So if you go to settings here, network adapter should be bridged for all the machines. And Metasploitable has two adapters. So both the adapters should be put in bridged. Adapter 1 and adapter 2. Okay. So that should be the issue. Right. So yeah, that's it, guys. Nothing further for our session today. We'll complete the remaining scan tips in tomorrow's class and also dive into options and map options. Okay. Yeah, Jeevan, go ahead. Sure. When you talk about local machine, are you talking about the base machine, Jeevan? And then that is not with the bridged or NAT again, Jeevan. Basically, it's your base machine blocking the packets. So if you go to your base machine and search for firewall here, so you should see something like firewall network and network protection. There, you should put the firewall off. So if you switch on the firewall here, so if I perform the firewall, if I switch on the firewall, let's say, and now if I try to ping to this machine, so let's say this machine is getting the IP of 0.3. So if I go to my Kali system here, and if I try to ping 192.168.0.3, I won't get any packets. If you see, it doesn't initiate the ping. But if I switch off the firewall, if I go to firewall and if I switch off the domain firewall, the private firewall, and if I switch off the public firewall also, because your firewall blocks these ping packets by default. So now when I ping, I get the packets. If you notice, earlier I wasn't getting any packets at all. That was 100% packet loss, but now it's 0% packet loss. So it's just the firewall, nothing with bridged or that. No, nothing should be with the internet again. Um, oh, again, I understood what your problem is, Jeevan. So that is not with your firewall or again, nothing to do with the base machine as well. Your system is not getting an IP at all. So in your bridged mode, if you type ifconfig, you will not have an IP at all. Okay. So I think I explained this problem to someone else earlier also. Who was that? Was it Shekhar or Bhavin? Bhavin, you. I think I explained it to you. So that was not an issue with your firewall here, G1. It was an issue with the network adapter. Were you not there in that class? I explained how to resolve that. Okay, let me explain. So when I shut down the virtual machine here, basically it's your problem with VMware. So your VMware is unable to get an IP address from the Wi-Fi adapter. So what you have to do is go to workstation. In workstation, you'll have this option called edit. Oh, 1 second, guys. Am I on? Yeah, I'm not on mute. So you have to go to workstation, you have to click on edit. And here in edit, you have to click on virtual network editor. So this is some issue with some VMware workstations. It is unable to figure out who the Wi-Fi adapter is. So here you have to click on change settings. And when you do that, you should get a screen as such. 1 second, it's still loading up. Mm, Yeah, this is the screen you should get. Virtual network adapt editor. And here in the bridge mode, your system will be connected on automatic. So in some of the systems, this automatic will work perfectly fine. But in some devices, it will not get what adapter to connect with automatically. So you have to click on this drop-down menu and you have to select your Wi-Fi adapter here specifically. If you want to figure out what is your exact Wi-Fi adapter, you have to go to your command prompt. And in your command prompt, you have to type ipconfig base machines adapter /all. When you type that here, you get the Wi-Fi adapter's name. So my system is using Realtek adapter, Wi-Fi 6 Realtek. So that same adapter needs to be mentioned here. Okay. So you're specifically telling VMware, this is the adapter you have to connect to in the bridge mode. Okay. And this is from where you have to get the IP address. So when your VMware is unable to get the adapter, you have to tell it manually. Look, here is where you have to get the IP from. So when you select that adapter, click on OK and apply. Then you will get an IP to ping to other systems or to also get the internet access. Okay. So that's the issue. It's nothing with the firewall again, G1. You can keep the firewall settings same. And to get IP to ping to internet, you have to just do this setting. Okay. So in my system, it works on automatic. Luckily I didn't get that issue. But if unfortunately if you do get it, you have to select the adapter manually, click on OK, and then apply. Then it should work. Okay. Is that clear? Right. So yeah, that's that. Nothing further. Figure again. Check that out once you. If it is still not working, just let me know. I'll try to connect to you separately, and then we can resolve the issue. But 99.9% this should work. It did work for Bhavin the other day, right, Bhavin? I think you had the same issue. Yeah, yeah. Oh, that also worked. That's right. Okay, okay. So you can try that as well. Again, G1, edit virtual network editor, and there's an option here called yeah, and then this. Okay, perfect. So you can try that as well, G1. If this doesn't work, then you can go for selecting the adapter manually. Any of this will work. Sure. Thanks, Bhavin. Right. So yeah, that's that. Any other questions, G1? Oh, again, you have this option, right, Bhavin? So on the top, if you see, you can just right click on this tab here. You have power and shut down. Okay, simply. Or you can also, There is a command. You can type systemctl power off. This also works. Oh, this is not working in this one. MSF admin. Oh, this should work in Linux operating systems. Maybe in Metasploitable it's not working. But basically, this is the command to shut down any Linux operating system. Systemctl space power off. Okay. But if that doesn't work, again, right click power shutdown. That's another alternative. Okay. Right. Any other questions, guys? Mhm. Mhm. Jeevan, I'm here. I am listening to you. Again, as mentioned, I think I explained this in the networking fundamentals class. Depends on your DORA process from DHCP. So if I go to my DHCP server here, if I open up a new tab, if I search for my router's IP, 192.168.0.1, so your router assigns IPs automatically due to the DHCP protocol. Okay, and that works. Uh-huh. Oh, public IP. Okay, go on. Uh-huh. Yeah, definitely. Your public IPs will always be dynamic. They'll never give you a static IP unless and until you're asking them for a static IP. So today, if you're using your cellular network, you might get an IPv6 address also. So here I'm using my Wi-Fi, which is connected to from ACT 5 minutes. So it's getting a public IPv4 address. And what address I get here today will not be the one which I might get tomorrow. It is always dynamic. It keeps changing. Because if you get a static IP, you can start hosting websites from your home, frankly speaking. So that is why they never give you static public IPs. They will always give you dynamic IP. Every single day, your public IP will change after every certain 12 hours or 24 hours time. Okay. So again, there is no rule that you have to get a same IP every single day, whether it be Wi-Fi networks or cellular networks, anything. Okay. So again, you can request for a static IP, but again, they'll ask you a lot of questions. Why do you need a static IP? Whatnot? Okay, because they're scared that you'll host your own websites from home. So you can ask them that you have an IP camera set up at home, and those cameras need to get a static IP every day. So if you give that reason, they'll charge you somewhat extra, another 500 extra rupees or so, and they'll give you a static IP. Okay. Unless and until you're asking them, they'll always give you a dynamic IP. Okay. Right. Bhavin, I think there's this command. They have mentioned one more command here. If I checked it out, there's a command called sudo shutdown -h now. Okay. So let's try that. Oh, perfect. Oh yeah, it's working. Yeah, that is the command. Right. Perfect. And Kali. Any other questions, guys? Yeah. Root. Always root. Right. Any other questions, guys? So I think in Linux, Kali Linux, this command works. Systemctl power off. As you can see, in Kali it is working. In Metasploit it is not. Yeah. Okay. Any other questions, guys? Oh yeah, I'm going to share that right away, Shiv. I'll share the record. Sure. Yeah, that's that, guys. Nothing further. Let's exit the session here. Connect back tomorrow to continue further on Enma. Bye bye. Good day. Take care. I'll see you tomorrow at the same. Thank you, guys. Bye.